Today we are going to discuss the topic called lecture number 32. It will be a terminologies of EMF equation of alternator and armature reaction. Armature reaction. Okay. So we already know that EMF equation of alternator. Can anyone tell me the EMF equation of alternator? What is the EMF equation of alternator? Anyone tell me? What is the EMF equation of alternator?
So 4.44 F5
What is a notation? EMF equation notation. E phase equal to
E phase equal to 4.44
4.44
F5
F5
T phase.
T phase. Okay. The unit of the EMF equation is volt. Okay. Now this is the general EMF equation. Okay, where F is the frequency, phi is the flux, and the T phase will be the number of turns per phase. T phase means number of turns per phase. It is a formula Z phase divided by 2, where T phase will be the number of turns per phase. Okay, Z phase divided by 2. This Z phase is nothing but Z phase will be the number of conductors per phase. Even many times I explained, that is I mentioned it, the class is taught purely recording it. For that purpose only I am instructing you to join in the class by 10:05 AM. Okay, even many times, that is some of the students are entering late. It is too much disturbing for me for recording purpose. Please understand my problem also. Number of conductors per phase, Z phase. So this is the general EMF equation. EMF equation 1. Now this equation we have to represent in terms of some factors. Okay, some factors we have to represent it. Okay, so how to represent this factor? Generally the EMF equation, this E phase, depends on windings. It depends on windings. Okay, because the windings will be classified into two types. One is single layer and double layer winding. So in both single and double layer, it mainly depends upon the full pitch and short pitch winding, because these are the factors. Short pitch winding in armature terms. Yesterday class explained it. There are three types of classifications are available in armature winding. One is single and double layer. Second one is full pitch and short pitch winding. What is the third type? What is the third name? Third name will be the concentrated and distributed winding. Okay. Third one is concentrated and distributed winding. So out of these three, this EMF, it depends upon two factors. One is, because this single layer and double layer will be a general term which is applicable in the machine. Okay, but EMF, E phase will be depends upon only these two factors. One is full pitch and short pitch. Another one is concentrated and distributed winding. Okay, the main idea of this concentrated and distributed winding, the windings are getting a proper efficiency, then we are going for distributed purpose. Okay, if you are getting very low efficiency, then we can go for concentrated purpose. So in both concentrated and distributor, there are two factors are produced. Two constant factors are produced. Two factors means it is the constant factors are produced. So what are these constant factors are available? Okay, in related to the E phase. So what I have to write? E phase equal to, okay, E phase is equal to 4.44, okay, 4.44. I have to include the notation Kc, Kd, okay, Kc, Kd into F phi T phase. Okay, because here this EMF will be directly proportional to 4.44 Fi T phase. When you take this proportional symbol, you will get a constant term. Okay, this constant term is nothing but Kc into Kd. Okay, constant term is nothing but K equal to Kc Kd. Okay, so now we will see what is meant by a Kc and what is Kd. First parameter will be Kc. Kc stands for pitch factor, or the other name of pitch factor, coil span factor. Pitch factor or coil span factor. Okay, coil span factor. So here the definition of this definition, it is defined as Kc is the ratio of resultant EMF. ER stands for resultant EMF when coil is short pitched divided by resultant EMF when coil is full pitched. Coil is full pitched. So for this ER stands for resultant EMF. Okay, note down. ER stands for resultant EMF. Okay, resultant EMF. So when the resultant EMF in coil is short pitched, the equation 2 into the total E into cos alpha by 2 divided by ER when coil is full pitched is 2 into total EMF E. 2 into total EMF E. Okay, normally we know that there are two coils we are placing. This coils, this is coil number E and this coil number E, coil number 1 and 2. The EMF produced here E and E. So the shape of this coil will be, this is the shape. Okay, the EMF will be going to the top layer, then it will be moving downwards to the downward layer. So the distance between these two coils will be 1 pole pitch. So what is the angle of these two coils? How much angle? Yesterday class mentioned it. What is the angle of
180 degree.
Good. It is 180 degree. Okay, it is 180 degree. And here you see the notation, this alpha. Okay, this alpha stands for short pitch angle. Short pitch angle alpha. Okay, so therefore we can write this Kc equation. So basic Kc, what is the equation? 2e cos alpha by 2 divided by 2e. Now what are the terms will be cancelled? Anyone tell me? E and E will be cancelled. Therefore we'll get Kc equal to cos alpha by 2. This is Kc equation. Okay, this Kc is nothing but, what is Kc? It is the pitch factor or coil span factor. Okay, this is Kc. Now next term, Kd. Kd stands for distribution factor. Okay, the definition of distribution factor, Kd equal to the ratio of resultant EMF when coils are distributed, to the resultant EMF when coils are concentrated. Okay, coils are concentrated. So the resultant EMF in coils are distributed, the formula 2 into the total resultant R. Okay, the total resultant R into sine because in winding the EMF will be distributed in terms of sinusoidal, so I am mentioning sine into m beta divided by 2 divided by, when coils are concentrated, at right, 2 into m or sine beta divided by 2. Okay, so here r and r will be gets cancelled and 2 and 2 will be cancelled, so finally we'll get sine m beta by 2 whole divided by m into sine beta by 2. Okay, now what is m? Okay, m means slots per pole per phase. M is the slots per pole per phase. So here in alternator we are giving how many phases are there? The phase value will be 3 RYB. Okay, the phase will be 3 phase. Okay, the phase is 3 RYB. The phase value will be 3. Okay, and slots per pole should be this beta. Okay, we have write this beta. Okay, beta also, beta means it will be a slot angle, therefore beta equal to 180 degree divided by n. This n is nothing but number of n is nothing but slots per pole. Okay, therefore m, how to write m equal to slots per pole, right? Slots per pole notation is n. Okay, n divided by per phase, how many phases? 3. M equal to n divided by 3. Okay, any doubts? So finally we can represent distribution factor is nothing but KD equal to sine m into beta by 2 whole divided by m sine beta by 2. This is distribution factor. Okay, distribution factor. Okay, now if we find by using this two formula, if we find Kc and Kd, then only we can write this equation EMF equal to 4.44 Kc Kd into F5 T phase. The unit for EMF will be volts. Any doubts? Till now you have doubts? Anyone? Shushma?
Yes, sir.
Any doubts?
No, sir.
Okay. And now we'll solve one problem. Okay. The problem is an armature of a 3-phase alternators has 120 slots. The alternator has 8 poles. Calculate its distribution factor. Okay, this is problem 1, first problem. Distribution factor. Okay, now we'll write given data. First we have to write the solution. Okay, now what they are asking? Calculate its distribution factor. Can anyone tell me what is the distribution factor formula? Anyone tell me? Distribution factor formula? Anyone? Anirudh? Gibran? Distribution factor formula KD equal to Sahana? Anyone?
So it is sine m beta by 2 by sine beta by 2.
Yeah, sine m into beta by 2. Okay, because in distributor the m is multiplied with an angle. Okay, inside the sinusoidal term. But in concentrated winding the m will be a constant term we have to take outside. M into sine beta by 2. This is a formula. Okay, now we have to find m value. What is m? M means what? Slots per pole per phase. Slots per pole per phase. So how many slots are there? Slots is how much? What is the m formula? M equal to slots per pole, right? So how many slots? Anyone? How many slots given in the problem? 120. Okay, 120 divided by per pole how much? It is 8. Okay, 8. How much? 120 divided by 8 whole divided by number of phases. Number of phases will be, sorry, here I have missed 3-phase alternator. So number of phases will be 3. So how much? What is the answer? Anyone? Give the answer. Because this 120 divided by 8 means slots per pole, right? We have to take the notation called n. N equal to 120 divided by 8. How much? Anyone? Gibran? Shushma? Harisha? Nishal Dinesh?
Yes, sir.
5.
Huh? How much? 5?
5.
Yeah, good. 5.
5, sir.
Okay. Therefore, then beta we have to calculate it. What is the beta formula? Beta equal to 180 degree divided by n. 180 degree divided by, what does mean by n? N is nothing but slots per pole. So slots per pole. So what is the value? N equal to slots per pole, right? slots means 120 divided by pole is 8. So how much? What is the answer? How much degrees? Anyone?
Well,
12 degrees, right? 12 degrees. Good. Now we will substitute all the parameter in KD. KD equal to sine of, what is m value? M is 5. 5 into beta 12 divided by 2 whole divided by m value how much? M 5. 5 into 5 into sine of beta 12 divided by 2. So how much ma answer? KD. Therefore KD equal to
0.956.
0.95.
707.
956.
No, 957 KD. Okay, are you understand this problem? Can we go on to second problem? Can I move to second problem now? Second problem. Problem 2. Problem 2. In a 4-pole 3-phase alternator, armature has 36 slots. It is using an armature winding which is short pitched by 1 slot. Calculate its coil span factor. Calculate its coil span factor. Solution. Coil span factor means, what is it now? It is a KD or KC? It is a concentration factor, right? KC. KC. What is the formula for KC? Anyone? KC equal to?
Cos alpha by 2, sir.
Yeah. Cos. Good. Cos alpha by 2. Where alpha is the slot angle. Cos alpha by 2. Okay. We know that we have to calculate the alpha. Okay, we have to calculate the alpha. So how to calculate this alpha? First we have to calculate this slot angle beta equal to 180 degree divided by n. So 180 degree divided by n value will be slots per pole. How many slots? It is 36, right? 36 divided by pole is 4. So how much beta ma? Can anyone tell how much beta? Beta value
20, sir.
20. It is 20 degree. It is 20 degree. Okay. Now take down Now coil is, in your question, the coil is short pitched, that is it will be shorted by, short pitched means, the meaning of short pitch means it is shorted by one slot. Okay, because from question itself they are providing coil is slotted by one slot. So one slot means, that is your total angle is beta. Beta is 20 degree to full pitch distance. Now tell me the coil of shorted by one slot. Okay, this is full coil. So if I consider for half of the portion, how much it is? How much alpha value? This is for full coil, 20. So if I consider for alpha for short pitch, that is nothing but 10 degree. Half of the portion you have to take. This alpha. Now this value substitute here. Cos of alpha 10, it is 10, this is correct, which I am writing here somewhat is not right. Okay, I'm confusing here. The coil is shorted by one slot, so your total angle is beta is 20. During short pitch winding, the alpha value which is equal to beta, so therefore alpha equal to 20. So this 20 we have to substitute here. 20 degree divided by 2. So how much? So cos of
0.984.
Yeah, 0. Therefore Kc equal to 0.9848. Okay, understand? So when the coil is short pitched by one slot, during that time the alpha value will be equal to beta value. Okay, alpha will be equal to beta. Please note down it. Please note down alpha equal to beta. Okay, now we will go to the third problem. A 3-phase 16-pole star connected alternator has 144 slots. Having 10 conductors in each slot. The flux per pole is 30 milliweber and distributed sinusoidally, and the speed is 375 rpm. Find the induced EMF for A subdivision, full pitch winding, B part, coils short pitched by one slot, C subdivision, coils shorted by 2 slot. Okay. Okay. Now we'll write solution. In your question, what they are asking you to calculate? You are going to calculate the induced EMF. Okay. So induced EMF equations are two types. One is E phase is equal to 4.44 F into 5 T phase. Another equation in terms of factors. Okay, in terms of factors means Kc and Kd. By using these two equations, I am going to represent the equation number 2. We know that E phase is equal to 4.44 Kc Kd, frequency of 5 T phase. So all these parameters now we are going to calculate it. Okay, the first parameter. Okay, the first parameter we can measure the Kd. We don't know Kd. Okay, Kd means distribution factor, right? Kd equal to sine m beta by 2 whole divided by m into sine beta by 2. What is m? M means number of slots per pole per phase, that is m equal to n divided by phase, 3 phase. Okay, this question will be carries, it will be a 3 phase, right? Okay, number of phases will be 3, so I have put n is number of slots per pole. Okay, so how much my m? N is how much? Number of slots how much? How many number of slots? 144 divided by m is slots per pole per phase, that is m. Okay, so 144 divided by pole is how many poles? 16 poles. 144 divided by 16 whole divided by number of phases will be 3. So what is the answer? M. Anyone tell me how much m? M value how much?
Three, sir.
3. So therefore m equal to 3. Okay, next beta. Beta you have to calculate. That is, beta is nothing but slot angle. Beta equal to the formula 180 degree divided by n, which is equal to 180 degree. This n is nothing but slots per pole. Slots per pole 144 divided by 16. So what is beta? Therefore beta equal to how much? Beta how much? Anyone? Beta? Please give the reply.
20, sir.
20, sir.
Good. Beta equal to 20 degree. Okay. Now can we substitute this both the parameter in your equation? Substitute here. Sine into m 3 into beta 20 divided by 2 whole divided by m value here 3 into sine of sine of beta 20 degree divided by 2. So what is KD, ma? KD how much?
0.9597, sir.
Yeah, KD equal to 0.9597. Good. This is KD. Okay, this is KD. Then in our EMF equation, KD we have done, okay, and KC, that I will explain what you have to do, and the frequency, whether frequency is available in your question anywhere. You see, check the question here. Any frequencies are available? Frequency anywhere? No, there is no frequency. Okay, only the flux is available. Flux per pole is 30 milliweber. Only this one is available. Now, how to calculate the frequency? So we have to write Ns equal to speed 120 Fs by P. Fs or F by P. Okay, so from this, F equal to, what is synchronous speed? Ns into P by 120. So how much Ns in your question? Anyone tell me? Ns speed is 375, right? This value substitute here. Speed is 375 into how many number of poles as per your question? 16 divided by 120. So what is the frequency?
50, sir.
Good. Frequency we can write Fs or F, both are same because it is synchronous machine, right? F equal to 50 Hertz. Okay, 50 Hertz, we got it. Okay, now we will go to our question. Then we have to find out the what is that as per your EMF equation. Flux is already available. Okay, the flux value is available in your problem. The flux value will be how much flux? The flux is phi equal to how much? It is 30 milliweber, right? 30 into 10 power minus 3 Weber. It is available in your question. Now T phase, we don't know the T phase. T phase means the formula for T phase, how to calculate T phase? T phase is equal to Z phase by 2. Z phase will be the number of conductors, number of total conductors. So what is the formula for Z phase? Z phase is equal to, it is total conductors, slots into conductors per slot. Okay, Z phase will be nothing but it is total conductors. Total conductors stands for Z phase. Z phase equal to slots into conductor per slot. So how many slots are available? As per your question, you see the question. How many slots are available? It is 144 slots. This value substitute here. 144 into how many conductors per slot? How many conductors per slot as per your question? Please check. 144 slots having 10 conductors in each slot. Okay, this value substitute here. 144 into 10. So you will get 1440. Therefore Z phase is equal to 1440. Okay, this value substitute in your T phase. T phase is equal to 1440 divided by 2. So how much my T phase finally? T phase equal to, give the answer. T phase, anyone? T phase is equal to how much? Number of turns per phase, how much? 1440 divided by 2.
Sir, 720.
720. It is 720. Okay, now I have done a mistake, right? Here you see, here it is Z phase. Okay, Z will be the total conductor, but here we have to find out the phase also, right? Okay, so how much it is? This is Z. This is Z, and Z phase means how to calculate it? 1410. This is Z. Z you are getting 1440. Now we have to calculate Z phase. Z phase will be how many phases as per your question? It is 3 phase, right? 1440 divided by 3. How much?
480, sir.
480. Okay, this value only you have to substitute here. So here I am writing 480. 480 divided by 2, how much ma? T phase. Z will be the total conductor, but we are calculating for Z, T phase. How much?
240, sir.
240. Okay, now go to our question. So as per our question, your first subdivision will be, we have to calculate the EMF induced for full pitch winding. Full pitch winding. Okay, so in full pitch winding, the factor, okay, the concentrated factor, that is Kc, will be 1. Please take down, in full pitch winding the concentrated factor Kc equal to 1. Therefore EMF equation, E phase is equal to 4.44 Kc Kd into 5 into frequency T phase. Now substitute all the value. 4.44 into Kc, in full pitch winding the Kc value should be 1. 1 into Kd, how much? What is the answer for Kd? You got it? 0.9597 into flux value 30 milliweber, 30 into 10 power minus 3 into frequency 50 hertz. Number of turns per phase will be 240. So what is the answer? Please give the answer.
1533.9844.
Yeah, E phase is equal to 1533.98 volt. Okay, 98 volt. Okay, now go to your problem. As per your problem, you see the question. A 3-phase 16 pole star connected alternator. Okay, it is a star connected alternator. You already know the basic idea about star and delta connected. Okay, in terms of star, okay, this is the star connected alternators. R, Y, B, this is neutral. In star connected alternator, the voltage, that is the EM line voltage, E line equal to root 3 into E phase. Okay, but the current I line equal to I phase.
I'm activating the link forward.
Okay, but in terms of delta connected alternator, this is delta connected, because in delta connected alternator, this is star, this is delta. Okay, so in delta connected alternator, no neutral point will be there. So the line E line equal to E phase and I line equal to root 3 into I phase. Please take down this formula. Okay, I line equal to I phase. Now by using these two formula, your alternator will be star connected, right? So what I have to write? Which formula? This is star connected. This one we have to write it. E line equal to root 3 into E phase. Root 3 into E phase. Therefore, root 3 into E phase is 1533.98. Therefore, E line equal to how much? It is 2656.94 volt. Okay, 93 or 94 volt. Okay, this is my first subdivision. And second subdivision will be EMF induced, but the coils are short pitched by one slot. In previous problem I told, if the coils are short pitched by one slot, what is the condition? What's the condition? Alpha equal to beta. So how much your beta value? It is already calculated, right? It is 20 degree. It's already calculated. Okay, in your problem itself you calculated just now. Okay, so therefore we have to find Kc value. Kc equal to cos, because cos alpha by 2. So cos of 20 degree divided by 2 will get 0.9848. Okay, now you write the EMF equation. E phase is equal to 4.44 into Kc 0.9848 into Kd 0.9597 into flux 30 into 10 power minus 3 into frequency 50 into number of turns per phase 240. So finally we'll get 1510.68
0.6679.
yeah, 679 means 68 volt. Therefore, since it is star connected alternator, we know that E line is equal to root 3 into E phase. Okay, so root 3 into 1510.68. So therefore E line is equal to 0.574 volt. Okay, this is second subdivision. And the third subdivision will be coils are shorted by two slots. Shorted by two slots means the meaning, because anyway it is shorted, so alpha equal to, we know that shorted means alpha equal to beta for one slot. Okay, here it is one slot, but here as per your question you see it is two slots. Therefore alpha equal to, instead of 1 I have to put 2. Okay, therefore alpha equal to 2 into beta. Okay, so how much your beta? 20 degree, right? 2 into 20 degree, so it is 40 degree. Okay, now please substitute all the parameter in your EMF equation. If you substitute it, we'll get E phase is equal to 4.44 into same Kc also we have to find out, right? Kc equal to cos alpha by 2. So cos of 40 degree divided by 2. So we'll get the 0.9396. So 4.44 into 0.9396 into Kd value 0.9597 into flux 30 into 10 power minus 3 into frequency 50 into number of turns per hour 240. We will get 144.3318 volt.
7.
Yeah, therefore E line is equal to root 3 into E phase. Substitute it, we will get final answer 2496.46
459.
459 volt. Okay, that's all. Okay.